So we will commence the second step is the verification of the member. So we have to, from here, we have two methods for verification. The first one, to create a group here and then let Robo optimize the section. If the structure is not very big, we can optimize it manually. So for example, we can look here, I can put the member. So here, for example, combination, we have to enter the, so, and then here I have all my member here. Let's take a look about the Berlin. So as we can see, all the Berlin is not okay. So we have a ratio about 10 here, for example here 11, and the charge is accidental. So it is the snow who do a problem. The placement, we don't have problem with the placement, so it's the snow, and we cannot put another anti-lateral buckling from here, for example. Berlin, I can put another layer. So but it doesn't change a lot. As we can see, buckling here, the longer of buckling is 1.5 in the axis of Z, and in the axis of Y we have 5 meters. Here, for example, bending moment, so we have a problem with the shear forces. We have 700% of extra shear forces. So it's better to change the section. So I will change the section, all the section. I will put so 100 like that, and then I will change yes, and I have to change the material too. So from here for all the member, for all the steel member. Here I save. So as we can see, it's pretty good, all is green. Maybe I can use EBE 100. So for example, I will select I recalculate. So we recalculate the structure. As we can see, we have we can accept 1%, for example. We can try to add another layer, for example. We can recalculate. Sometimes we can accept some profile. Say, so for example, if I %, so I can find out what the changes. So I will find where is the problem. So the problem is here, as we can see. So we can change the first line and the last line with or we can reduce the interacts between we have a big span. So for this reason, the section of the purlin they cannot support. So we will change all the so here I can change. Like that. So I can recalculate and see if we have any disorder. Oh, it's good, it's pretty good. So we can take, for example, so it's good. So we can here, for example, put one LL, one anti lateral buckling, a place to 2, because here we put it 2 anti-lateral buckling, but here, for example, we can Berlin. So I can change the value. It's more economy, and here I will choose so it's work and it is more economy. So we can see the bending moment in the direction of X, direction of Z, not X, is more important now, because we delete the anti-lateral buckling, so we are good here. Now for the frames, so here we can we'll check the column here. Without the bracing, So the column is okay. So we can use another type of column. So we can, for example, change it, or we can use here copy, for example, group 1, and here and here, for example, I can, this is the section by group 1, optimize, okay, calculation, so change all, yes. So here they change it to 270. It's more economic too. Okay, and the same thing we can try with the frame, with the portic beam. Can try with the beam. So so we have a problem. We have a big problem. We can put anti-lateral buckling cornea in the middle of the span. It can reduce the lateral buckling. So shear forces, so it is not okay. We have bending moment, is not okay. So it can be solved if we added lateral buckling here. So we can here change the parameter, so lower flank, but it's better, maybe it can work. So we can recalculate. So here 13 we have minus 70%, here 60%, as we can see. So it is good. Or we can here change the group and we can delete. We can delete the anti-lateral buckling. So 2 here, save, we can see what type of section we need. He finished to calculate and he find we have to change the section to 450. So it is so big, so we can change from EBE 330 to EBE 450. So we have another alternative solution. We can change the dimension of the structure. Here the problem comes from the accidental niche. So we need to transfer the bending moment to normal forces when we raise the inclination of the structure. But in these cases we receive more wind load, but it is not a problem, it's a solution. Or we can change the profile, but we need to change the profile of the column in the same way. Or for example, we can add Bracon to our structure, and that imposes to us to more work time in the site work. Or the second solution, to add more than anti-lateral buckling. It can work. Or add we can add truss beam under our beam. It can be work too. So for me, I will try to add anti-lateral buckling. From here I will change the parameter. So beam and it is not expensive because it's depend to the section. Here we have EBE 330, so we use corner, we use steel corner 2023, because we need to consider 2% of the lower flange area. So I will put like that. it doesn't work. There is another solution. So we have problem of stability. Even if I try, for example, so it's work. I need, if I so it work. So we need to put anti-buckling. This method can work. We need to put two anti-buckling according to the error code. The section of anti-buckling, we have to apply this formula. Normally it's the same section or a section lower than the existing section. So we have two cases. We have unstable node or fixed node. So it's okay, but I need to change this column for the connection. We need to use the same profile. The last section is so what can tell us? Maybe we can use EBE 140. I will check that. So here my third group, save, and here so it will calculate automatically, and we will see if EBE 140 will fit the section. Here, as we can see, we receive a lot of wind forces, and and we can see a big part of the snow loads transfer to normal loads, and this section work in compression. So there isn't important bending moment here. That explains why, and the span is not very big. So it takes time. I will change it manually. It's so here so as we can see 140 it fits the structure. So we have 97%, so it's okay. Now the last step is bracing. I will be sure all the bracing this. What they can tell us about bracing. In why we have a problem, we can define which bumper so this element is not okay. We can divide it by 2 from here to here and from here to here. So we can it's instability elastic. So as we can see here, we don't have a lot of effort. It's just instability elastic. So the other bar, so we can use a section, a lower section. We don't have a lot of effort here. So for example, we can use this method, but it takes time. So I prefer, according to the result, I prefer to use, for example, 40, 45, even 35, and okay. Can run the calculation. So here we have 29%, 54. We have some issues with the cornea, corner angles. We can change it, not a problem, but we can use another. We can use for example, or I can use this type. Can use here blade. I will still angle. So here So we have 62, we have 80, we can use 20, 23, it can fit the effort here, not a problem, and we can change here the corner angle. So it's all for this video. See you in the next video. Don't forget to put like and subscribe.